Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIO level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did exercise 11.4 till question number 10. And the topic of this exercise is geometric sequence and geometric series. Students, before I start next question, I would suggest all those students who are watching my lecture first time, kindly first go to my playlist. There is a folder, name is AdMath. Watch previous lectures. After watching previous lectures of this exercise, you will have good command on this topic. So let's start question number 11, exercise 11.4. Question number 4 is find the sum of the first 8 terms of each of these geometric series. Students, for sum of geometric series we should have two formulae of sum. Formula number 1 is Sn is equals to A multiplied by R to the power n minus 1 upon R minus 1. Provide R should be greater than 1. So if the ratio of the given question is greater than 1, then we have to use the formula Sn is equals to A into R to the power n minus 1 upon R minus 1. And next, Sn is equals to A into 1 minus R to the power n upon 1 minus R. We will use this formula if R is less than 1. If the ratio is greater than 1, we have to use formula number 1, and if the ratio is less than 1, we use formula number 2. So question number 1, part A, find the sum of the first 8 terms. So series is 4 plus 8 plus 16 plus 32 plus and so on. So the first term is A, that is 4. The common ratio is R is equals to 8 upon 4, that is 2. And the number of terms obviously given in the question, that is 8. In each part we have to use n is 8. So because R is greater than 1, so we will use formula number 1, that is Sn. Here n is 8. S8 is equals to A. A is 4 into R 2 to the power 8 minus 1 upon R minus 1, that is 2 minus 1. So by using scientific calculator you can easily find the final answer in single step. So I am also using my scientific calculator. Four into 2 power 8 minus 1 upon 2 minus 1 is 1, so therefore we will just multiply 4 into 2 power 8 minus 1, and the answer is 1020. Answer is 1020. This is our final answer. Now do part B. 729 plus 243 plus 81 plus 27 and so on. So A is 729, R is 243 upon 729, and the answer is 1 upon 3. positive 1 upon 3, and 1 upon 3 obviously less than 1, so we will use second formula, and n is same, that is 8. Hence sum Sn S8 is equals to A is 729, multiply by 1 minus R is 1 upon 3 to the power n is 8 upon 1 minus R is 3. So use scientific calculator to find the final answer. There is a button of fraction in your calculator, so use that button to find the full and final answer. So the final answer is 3280 upon 3. 3280 upon 3, and you can write this answer in terms of mixed number, that is 1093 whole 1 upon 3. So this is our final answer. Very easy questions. Move to part C. Part C is 2 minus 6 plus 18 minus 54 plus dash dash dash. So here first term A, that is 2, R is obviously minus 6 upon 2, that is minus 3, and minus 3 is less than 1, and n is 8 for all parts, because we need first 8 terms, sum of first 8 terms. So S8 is equals to A, that is 2. We will use second formula, 1 minus R is minus 3 to the power n is 8 upon 1 minus, and R is minus 3. So use scientific calculator to find the final answer. Final answer is minus 3280. Minus 3280. This is our final answer. So very easy parts. D, minus 5000 plus 1000 minus 200 plus 40 minus and so on. So the first term is A, that is minus 5000. R is 1000 upon minus 5000, that is minus 1 upon 5, and obviously minus 1 upon 5 is less than 1, and n is 8. So S8 is equals to A, that is minus 5000 1 minus r, r is minus 1 upon 5 to the power 8 upon 1 minus r, 1 minus 1 upon 5. So use scientific calculator to find the final answer. Final answer is minus 4166.656 minus 4166.656. This is our final answer. So hope you understand entire question 11. Here we have learned that how to find the sum of the given geometric series for the required terms. Like in question number 11, the requirement is to find the sum of first 8 terms, and we have fulfilled the requirement. Now move to question number 12. Question number 12. The first 4 terms of a geometric progression are 1, 3, 9 and 27. Find the smallest number of terms that will give a sum greater than 2, 2, 000, 000. So find the smallest number of terms means we have to find the value of n. That is the number of terms. So start. First term is 1. The ratio is 3 upon 1. That is 3. So r is greater than 1. So we will use formula number 1. That is Sn is equals to a r to the power n minus 1 upon r minus 1. Now the question is, find the smallest number of terms that will give a sum greater than 2, 000, 000. Greater than a. Why we use greater than? Because this is a question, sum greater than of the given value. A is 1, r is 3 to the power n minus 1 upon 3 minus 1. So 2, 1, 2, 3, 1, 2, 3. 1 doesn't impact anything. So 3 to the power n minus 1 upon 3 minus 1 is 2. This 2 is divided over here. This should be multiply on other side. It is 4. 1, 2, 3. 1, 2, 3. 3 power n minus 1. Shift this minus 1 on other side. It should be plus 1. So it is 4, 0, 0, 0, 0 0 1. In order to find the value of n, we should take logarithm on both sides. So log 400 0 0 0 1 divided by log 3 greater than n. Use scientific calculator to find the value. The answer is 13.837. 13.837 greater than n. So one thing which I miss over here, I should put a less than sign because the sum is greater. So I have to put less than sign. Now the value of n is greater than 13.37. And you know the number of terms cannot be right in terms of decimal. So the first whole number after 13.837 is 14. This is our final answer. So sorry for that. I put wrong inequality sign, but I have correct. This is also. So very easy question, very interesting question as well. Move to question number 13. This is the whole question number 13. A ball is thrown vertically upwards from the ground. The ball rises to a height of 10 meter and then falls and bounces. After each bounce, it rises to 4 upon 5 of the height of the previous bounce. Part A. Write down an expression in terms of n for the height that the ball rises after the after the nth impact with the ground. Part B. Find the total distance that the ball travels from the first screw to the fifth impact with the ground. So this is the word problem, or you can say application of geometric series as well as geometric sequence. Let's draw a rough graph of this question. A ball is thrown vertically upward from the ground. Let us suppose this point is ground. This is the ground. The ball rises to a height of 10 meter. So this is the height, 10 meter. This is the final position of the ball. And then falls, bounces, and then falls, and then bounce like this. After each bounce, it rises to 4 upon 5 of the height of the previous bounce. This is very important. If you are a student of physics, you know the energy conversion. When the ball bounces to the ground, that sum of its energy converted into heat energy. Therefore, the ball must not bounce to 10-meter height again. And then next falls, the height is again 4 upon 5th of the previous height. So I hope you understand. Now coming about the geometric sequence. Write down an expression in terms of n for the height that the ball rises after the n impact with the ground. So students, at first At first, the height was 10. Next bounce, the height was 10 of 4 upon 5 according to question. The next height is 10 4 upon 5 into 4 upon 5 and so on. Now see carefully 10, 5 2s are 10, 2 4s are 8, 5 2s are 10 and 2 4s are 8, 8 4s are 16, 16 upon 5 and so on. Now check what is the ratio. Check what is the ratio. Sorry, 4 4s are 16, 16 2s are 32. Check the ratio. 8 upon 10 is 4 upon 5. 32 upon 5 is divided by 8. It is 32 upon 5 into 1 upon 8. 8 4s are 32. So this is the geometric sequence. In this geometric sequence, A is 10. Obviously, R is 4 upon 5 and N is N. Okay. Now, we have to use the formula Tn is equals to A R power N minus 1. But one thing which is very important, for example, look at this. If I find T1, A is 10 dot R is 4 upon 5, N is 1 minus 1. Answer is 10. Next, 10, 4 upon 5. Now I am going to find the second term. So 2 minus 1 is 1, 5, 2s are 10, 2 4s are 8. See, Tn is equals to A is 10 dot R is 4 upon 5 to the power N minus 1. So for N is equals to 1, that is the first term we can achieve. The first term is 1 minus 1 is 0. So 4 upon 5 to the power 0 is 1, that is 10. For second term, 4 upon 5 to the power 2 minus 1, 2 minus 1 is 1. So the second term would be 8. Okay. But students, look at carefully the word. Write down these part A. Look this part. What they want, write down an expression in terms of n for the height that the ball rises after the nth impact. Means after the first impact, after the second impact, after the third impact after the fourth impact. So they doesn't need the last term, they doesn't need the first term. So we should write 4 upon 5 to the power n. So for n is equals to 0, look carefully. For n is equals to 0, the answer is 4 upon 2, 5 to the power 0. Something to the power 0 is 1. Then 10 ones are 10. Then for 1, we will get, for n is equals to 1 means the first impact. So this is our final answer. So they doesn't need the total impact, they need the first impact rises after the nth impact with the ground. So kindly see carefully this part, because we doesn't put n minus 1, we just put n. Now see the second part. If you have any problem for this part, write in comment box, I will explain again. Find the total distance that the ball travels from the first throw to the fifth impact with the ground. Very easy question. Because r is less than 1, so we use this formula. Sn is equals to a 1 minus r to the power n upon 1 minus r. Sn, they need the total distance through the fifth impact. So S5 is equals to a it is 10, 1 minus r, 4 upon 5 to the power 5 upon 1 minus 4 upon 5. The answer is 33.616. But this is not the final answer, because we need the total when the ball goes up and the balls goes down. So we should multiply this answer by 2. So we will get the final answer 67.232 meters. This is the final answer of part B. So hope you enjoy this question, but I got little bit confused about this question. Let's start question number 14. The third term of a geometric progression is 9 times the first term. You know, geometric progression is AR, AR square, AR cube, and so on. This is the geometric sequence because the ratio is same. Now according to the question, the third term, that is T3, is equals to is 9 times the first term, that is 9T1. So T3 is, look at it over here, that is A R square is equals to 9 times T1 is A, because the first term is always called A. So AR square minus 9A is equals to 0. Taking A is common, R square minus 9 is equals to 0. This implies that R square minus 9 is equals to 0. R square is equals to 9. R is equals to plus minus 3, because we take root on both sides. Now I am reading the question again. The third term of a geometric progression is 9 times the first term. The sum of the first 4 terms, this is the second part, sum of the first 4 terms is k times the first term, or you can say the sum of first term, the sum of first term, that is S1. So because R is greater than 1, so we will use the formula Sn is equals to A R to the power n minus 1 upon R minus 1. So first we will use the positive R, that is S4. What is A? That is A is A. I will use direct the formula S4, that is A is A, R is 3 to the power n, and we will put 4 minus 1 upon 4 minus 1. This is the sum of first 4 terms. R is 3 is equals to k time the sum of first term. You know, first term means A. So A cancel by A, 3 power 4 is 81, 81 minus 1 is 80, 80 upon 2, that is K is 40. So when R is equals to positive 3, the answer of K is 40. Next, we will put R is negative, that is A into negative 3 to the power 4 minus 1. Okay, I am doing over here because no more space. A into negative to the power negative 3 to the power 4 minus 1 upon negative 3 negative 1 is equals to Ka. A cancel to A. Negative 3 to the power 4, negative to the power even is positive, that is 81 minus 1. Minus 3 minus 1 is minus 4 is equals to K. 81 minus 1 is 80 upon minus 4 minus 20. Hence, the values of K are 40 and minus 20. Final answer of question number 14. That is why they ask find the possible values of K. So there are two possible values of K, that is 40 and minus 20. So that's it for today. We did question number 11, 12, 13 and 14. So only two questions are left in this exercise, which we will do in next lecture. So hope you enjoyed today's class. Very soon we will finish this chapter. Very easy and very important according to the examination point of view. So if you like my videos and if you think that my videos are helping you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Good luck for next lecture.